When I was in high school, I really enjoyed learning about chemistry actually, so atoms, molecules, electrons, things like that. And then I had the chance to work in a polymer lab for a summer research project where I really enjoyed kind of like mixing things together, doing reactions. And so for my undergrad, I actually did chemical physics, so I didn't want to choose between chemistry and physics because I wanted to explore more about those two different types of ways of seeing the world. And it was then that I saw this outreach talk about kind of nanotechnology, which I thought was a really interesting interdisciplinary way of seeing new materials and science in general. And so that's why I then decided to do a PhD in kind of nanotechnology and materials. So I'm a PhD student here at the Cavendish, and I look at using optical and magnetic resonance techniques to study new materials for applications in quantum technologies. So we're interested in seeing how light interacts with the materials that we're interested in, and then what that tells us about the fundamental physics of what's going on with the electrons in our material. And the idea is that the defects in the material that I'm studying could be used as qubits in solid state kind of quantum optical systems in the future. So there's a lot of hype now around quantum computing, but also we don't need to wait until quantum computers exist and are in everyone's pocket for quantum technologies to be important. So there's a lot of work going into quantum sensing, where essentially these new types of systems and materials where we're exploiting the quantum mechanical properties of new materials can give us like a new scale at which to do a sensing or give us new accuracy or new ways of sensing things. So things like magnetometry, thermometry, biosensing, but also in terms of kind of quantum information applications as well. In the future, if we do have a world of quantum computers, we'll want to connect those different nodes through kind of quantum communication networks. So the same way that we send information from one space to another using light. Nowadays, in the future, we'll have to send quantum information from one place to another, and that's where these new types of materials will come in to provide something that we can use to do that at those nodes.